Hi, it's me, Mr. B. In this video, we're going to discuss Z-score. We learned what a standard deviation was, and now we're going to learn what to do with it. We're going to apply it to what's called a Z-score, and we're going to be able to compare two different values to see which one is bigger, which one's smaller. We're just going to be able to compare things that aren't necessarily the same. So you can see here that Z-score is a standardized value that measures the distance of each data value from the mean in standard deviations. So basically it's this: if my number is 2 standard deviations away from the mean, then the Z-score is 2. So it just tells you how many standard deviations something is from the mean. You can see the equation there: Z equals x minus mu all over sigma. Mu is the mean, so this is the mean, and sigma is the standard deviation. My x is the actual value that I want to find the Z-score for. So that's the value. All right, so I'm going to use my height and my wife's height. And I'm going to see who is taller, me or my wife. Well, I'm 6 feet tall, and my wife is 5'3". So I'm 72 inches tall, she's 63 inches tall. Well, obviously, I'm taller. There's no doubt about that. I'm 9 inches taller than she is. But what I want to do is actually compare my height to the average man's height and her height to the average women's height, because they're really not the same if I just compare myself to my wife, because men are normally taller than women. So you can see there on the screen that the mean height of a man in the US is 69.5 inches and the standard deviation is 2.8. So that has been measured, and those are actual values. The average height of a woman is 64 inches and their standard deviation is also 2.8. All right, so I want to figure out what the Z-scores are for both me and my wife. So I want to figure out my Z-score first. So I'm going to find my Z-score by taking my value, which is 72, minus the mean, which is mu, and that was 69.5, over the standard deviation, which is 2.8. And I plug that in, and I get 0.89 for my Z-score. So I am 0.89 standard deviations above the mean. I'm almost 1 standard deviation above the mean, but I'm not quite. All right, let's go over to my wife. She is 63 inches tall, and the average women's height is 64 inches tall. So she's actually below the mean. And then I'm going to divide by the standard deviation, which is 2.8. And her Z-score turns out to be negative 0.36. So because she's below the mean, her Z-score is actually negative. So if my Z-score is positive, I'm above the mean. If my Z-score is negative, I'm below the mean. Well, since my Z-score is higher than my wife's, so 0.89 is higher than negative 0.36, that means I'm taller relative to an average man than she is to an average woman. In fact, she's shorter than the average woman because her negative Z-score shows this. All right, so let's do a few examples. So the average score earned on an Algebra 2 test is 82. So that means my mu is 82. And a standard deviation is 3. So that means my sigma is 3.0. Todd earned a 90. What is Todd's Z-score, and is he considered an outlier? All right, so let's figure out his Z-score. So the Z-score is x minus mu all over standard deviation, sigma. So x is what he earned, so that's a 90, minus 82, which is the mean, all over standard deviation, and we get 2.67. Okay, so his score was 2.67 standard deviations above the mean. So is he considered an outlier? And the answer here is yes, he is considered an outlier because his Z-score is higher than 2, which means he's more than 2 standard deviations above the mean. And remember, that's what the definition of an outlier is. If I'm more than 2 standard deviations, and that's above or below, above the mean or below the mean, then that means it's an outlier. So since his standard deviation, or since his Z-score is so much higher, is high, then that means he is an outlier. All right, on the same Algebra 2 test, Lisa earns a 64. So the only thing that's going to change here is her score. My average and my standard deviation are going to stay the same. All right, so her score is 64 minus the average, which was 82, over the standard deviation, which was 3.0. So 64 minus 82 is a negative 18, and negative 18 divided by 3 is 6. So my z-score here is negative 6. So she is really considered to be an outlier. To have a z-score of 6 above or below, a positive or negative, is very, very, very unusual. So she earned a very low score compared to everybody else in the class. So is she considered an outlier? Yes, absolutely, she is an outlier. More so than Todd was in the last example. All right, the average time required for Alan's teammates to run 400 meters is 82 seconds. So the mu, or the average, the mean, is 82. The standard deviation is 6. And Alan's time was 82 seconds. So what's his z-score? So x minus mu all over standard deviation. So his value was 82, his time. The average was also 82, and the z-score was, standard deviation was 6. So 82 minus 82 is 0 over 6, which gives me a z-score of 0. So if the z-score is 0, that means he is right on the mean. So he has no standard deviations away from the mean. He is right on the mean. So his z-score is 0. He is obviously not an outlier because he is right at the mean.